Okay, so this is review for today's test. Okay, on this test, we spent the entire week learning how to classify equations, and there were 5 classifications. Five classifications of chemical equations / reactions. Remember that equations are just symbolic representations of reactions. Equations are the symbols on the paper. Reactions are the things that actually happen between chemicals. Now you need to do the practice with me. You need to take notes with me. There's something called kinetic learning. And in kinetic learning, you do things with your hands that help you learn things. Note-taking is part of that. Practicing is part of that. So there are 5 classifications, starting with synthesis. And then we learn to do decomposition. And then we learned combustion, or the simple combustion system we're going to be using in this class. Single replacement was next, or single displacement is what I prefer. And finally, double replacement. A synthesis reaction in general form were 2 very simple chemicals combining together to make a larger or more complex chemical. Decomposition was kind of the reverse of that, where you have a larger or more complex form breaking up, decomposing, if you will, into smaller or simpler chemical forms. Combustion's a little bit harder to write down as a simple sort of general equation like this, because with combustion you're going to have a hydrocarbon fuel, and that is some chemical with a carbon and hydrogen ratio of some kind. We don't know how many carbons or hydrogens, so we could write that as CX or CY, and we don't know even its physical state, so we can put a question mark here. We don't know whether it's going to be solid, liquid, or gas. But that hydrocarbon is always reacting with atmospheric oxygen, and the products are always the same. CO2 gas, carbon dioxide gas, and steam, which is gaseous water. Okay? No, I didn't provide any coefficients on this. We don't know what coefficients would belong there. Depends on how you balance the equation. Balancing the equation was something we learned last week. Now, single displacement means we have some element that is going to displace some part of a compound. If A replaces B, then you get AC plus B. B ends up being by itself. We could also have, and I should have left a little more room here, I suppose, where A and BC react together and A displaces C, leaving C by itself, and then you have BA plus C. So those are both single displacement here. Now, double replacement means I have 2 two-part compounds. So this would represent a single one of the 2-part compounds. This would represent another one. A is going to join up with the back of this. The front of this joins to the back of this. Front part always stays front part. AD. Front part always stays front part. The front of this joins with the back of that. CB. It doesn't really matter whether CB is written before AD. Okay, you could write it Okay, you can reverse these two and get that. Doesn't matter whether this comes first or that comes first. Okay, so those are the general forms. If I give you a few reactions and ask you to classify them, let's list a few, and I'll go over how to classify them with you. Now, what I have here are two simple compounds coming out of one larger or more complex compound. So this is decomposition. You can also decompose a more complex compound into just elements, such as when we took water and we ran electricity through it. With some kind of salt or ionic compound in the solution to conduct electricity. We did that in the Hoffman apparatus. We showed you that. It was a demonstration in class. So this broke down into hydrogen gas and oxygen gas. I'm balancing the equation by putting those coefficients there. This is also a form of decomposition. Both of these represent AB becoming A plus B. All right, let's do this. I hope you're writing these down, and it's certainly fine for the teacher to pause the video and let you write it down and try to classify it yourself. That would be preferable. You'll learn a lot more by trying to do it for yourself, and then once you try it, have the substitute restart the video after pausing it and allow you to see whether you were right or wrong and why you might have been right or wrong. So now's the time to pause it. And if we didn't pause it, or if we're ready to go ahead, then we're going to look at this. Well, this is a carbon and hydrogen. That makes it a hydrocarbon. Hydrocarbons reacting with oxygen, atmospheric oxygen, producing CO2, known as carbon dioxide, and steam, which is water, H2O, as a gas. By definition, that's combustion of the type that we're using in this class. And that's the way combustion looks. Okay. Excuse me. All right, so this is aqueous and aqueous, solid and solid. Sorry, aqueous and aqueous, solid and solid. Now's the time to have the substitute pause the video if you want to write this down, and I recommend highly that you do that. Write it down, classify it yourself. You're certainly welcome to talk about it amongst your peers if you will do so quietly. Okay? Pause the video and we'll come back and we'll explain it. Okay, So what I have is an element by itself, a compound that contains a metal. This is also a metal. So that's an element that's like this one. And this element here goes over and kicks that out. And then this element and the back part of this compound end up together. Okay? So this and this join up together to make this. And it kicks this one, Cu, out by itself. So this might be called A, B, C. This would be the B part. The SO4 will be the C part. Then A is ending up with the C part. A and C. And this over here is B. Well, that's the way that single replacement or single displacement works. So the classification of this compound or this equation is single displacement. Here's another reaction. That's supposed to be an L, NaCl. Okay, so if you want to do this one first, write it down, try and classify it, talk to a learning partner if you want to, compare notes, and then ask the substitute to pause the video. We'll come back, we'll look at how well you did. Okay, so this is an element by itself. Yes, it's got a 2 here, but there's nothing else combined here except one element. So this would be considered like an A. Here we have 2 different elements, a metal and a nonmetal. That's a 2-part compound like B and C. Now, notice Cl is joining up with B over here. NaCl, NaCl. A and B, or rather B and A, B and A. Okay, Na is B, Cl is A. Br, even though it has 2 of them here bonded together, it's still Br, it's the C part. And this is also an example of single displacement. All right, let's go to another type of reaction then.